Hello. Today we're going to be taking a look at the Pythagorean Theorem. This one section has a lot of material in it, so I'm going to break it up into several days, and the same thing with the next section. So for the next few days, we're going to be taking a look at Unit 3, Section 1. It's going to be the Pythagorean Theorem. We'll start with things that we know, and then we'll branch out and expand our knowledge about the Pythagorean Theorem. So let's go ahead and jump in. So we got the Pythagorean Theorem. Okay. The Pythagorean theorem states that in a right triangle, the sum of the length of the legs squared is equal to the length of the hypotenuse squared. So, of course, you knew that. So, our formula is a squared plus b squared equals c squared. That is the Pythagorean theorem. If I label that in our triangle here, it doesn't matter which sides are the legs. I will go ahead and put our right angle mark in. It doesn't matter if this is A or this is B, or if this is A and this is B. It doesn't matter. Your legs are interchangeable, but always across from the right angle must be your hypotenuse. So the longest side is C, that's your hypotenuse, and then the other sides are A and B. And again, if you put A here and B there, same thing. Your legs are interchangeable, but this side here must always be the hypotenuse. So across from your right angle always has to be the hypotenuse. So let me draw something in here. Okay, so always across from your right angle mark must be the hypotenuse, which is the longest side. So always the longest. I'm writing in that the hypotenuse is always the longest side. All right, so that is just us filling in some vocabulary, making sure we remember our formula. A squared plus b squared equals c squared. Now let's get into some examples. And I'm going to write the formula right here so it stays in our viewing area. So a squared plus b squared equals c squared. All right, so the first one's very straightforward. 8 and 6 are the legs, and we're looking for the hypotenuse. So when we set up our formula, 6 squared plus 8 squared equals x squared. And it doesn't matter if this is 8 and this is 6, your legs are interchangeable. It doesn't matter which one you write first, but x has to be the hypotenuse. So we'll go through mental math, Desmos, whatever helps you out there. I get 36 plus 64 equals x squared. We add this together, we get 100 equals x squared. Take the square root of both sides, and we get 10. So the length of my hypotenuse is 10. So we started with 6, this is 8, and x ended up being 10. So that's the length of our hypotenuse. Let's try example B. This time we're given the hypotenuse, we're given one leg length, and we're looking for the other. So 8 is a leg, x is a leg, 12 is the hypotenuse. So when I set up my formula, x squared plus 8 squared equals 12 squared. So x and 8 are interchangeable. Makes no difference which one goes where, but just make sure 12 has to be in spot of the hypotenuse. So this gives me x squared plus 64 equals 144. So mental math or a calculator, we need to subtract 64 from both sides. Subtract 64, subtract 64. I'm going to get 80 once we do that. And take the square root of both sides because it's the opposite of squaring something. So x equals the square root of 80. Now this one turned out to be a whole number. I got 10. No decimals, fractions, nothing. It worked out to be pretty, so to speak. This one is the square root of 80. So I need to break down the square root of 80. So up here, I'm going to do a little factor tree for 80. So I'm going to break down 80. So two numbers that multiply to give me 80. There are lots and lots of things that multiply to give you 80. I could do 8 and 10. I could do 4 and 20. There's probably some other ones out there, but those are the first two ones that popped off the top of my head. So as long as you start your 80 off with something that multiplies to give you 80, you're going to be fine. So I'm going to start with 10 and 8. So again, you didn't have to start off with that if you wanted to try 5, if you wanted to try 20. It doesn't matter. Just make sure you start your factor tree off with two things that multiply to give you 80. This one is 5 and 2. This is 4 and 2. Okay. Prime number, prime number, prime number. I can break 4 down. Okay. We're looking for pairs of the same number. So are there two of the same number? I see two twos there, I can circle. I see two twos here, I can circle. So regardless of what you started with, even if you started off with 20 and 4 or some other pairing that multiplies to give you 80, you should have got this down at the end. You should have got 4 twos and a 5. Pairs go on the outside, and since I have multiple pairs, I'm going to multiply that. I have one pair of 2, another pair of 2. 2 times 2 gives me 4. And your leftover prime numbers go on the inside. That gave me 5. So the answer to this is 4 square roots of 5. And as a decimal, that gives me 8.94. So this is our final answer. So depending on the directions, if the directions say give it to me as a decimal, give it to me as a decimal, and we can round to the nearest hundredth. If the question says give it to me as a radical with the square root, then you would do this one. So go ahead and get in the habit of making sure you know how to do both. So 4 square roots of 5 and then 8.94. So radical answer, meaning the square root answer, and this is my decimal answer. All right. We'll go through the same thing. We'll see what kind of information we're given. This is my right angle. Across from the right angle is 14, so that is the hypotenuse. So these two are the legs. So if I set up my equation, 6 squared plus x squared equals 14 squared. The longest side must always be the hypotenuse, and it's always directly across from the right angle. So if I go directly across, that is where we will find the hypotenuse. So we go through, we do our thing, 6 times 6, 14 times 14. This is a positive 36. We move to the other side by subtracting. So this is positive. We're going to subtract 36 from both sides. So subtract 36 from both sides. That gave me 160. Square root both sides. That gives me x equals the square root of 160. All right, we're going to go through. This is definitely a number. I need to do a factor tree and see if I can break it down. So we're going to do a factor tree and see if I can break it down. So I'm going to find some space, probably over here to the side, and I'm going to do a factor tree for 160. So I'm doing a factor tree for 160. There are lots and lots and lots of things that multiply to give you 160. So just make sure you start off with two numbers that multiply to give you 160. I'm going to do 10 and 16. No particular reason. Those are just first thing that popped in my brain. So I'm going to do 10 and 16. Break down 10, it gives me 2 and 5. Break down 16, it gives me 4 and 4. Break down 4, gives me 2 and 2. And another 2 and 2. So I'm doing a factor tree for 160. 10 times 16, break down 10 into prime numbers, break down 16 into prime numbers. Now I'm looking for pairs of the same number. So 2 of the same number. I see 2 twos. I see 2 twos. And that is all the prime numbers that I see. I can't choose these 4. They're composite. So these are the prime numbers that I see. Pairs go on the outside. So I have one set of 2. And another set of 2. So that gives me 4 because 2 times 2 is 4. Leftover prime numbers go on the inside. So this is 2 times 5. That's 10. And of course, we can stick this in decimals and get a decimal approximation and round to the nearest hundredth. That gives me 12.65. So my final answer is 4 square roots of 10, which is approximately 12.65. Again, depending on directions, if it says give it to them as a decimal, you'd use 12.65, so 12 and 65 hundredths. If it says an exact answer using the square root, we say 4 square roots of 10. So that is a Pythagorean theorem. Last thing I want to get into today is something called Pythagorean Triple. Okay, so a Pythagorean triple, they are three positive numbers that satisfy a squared plus b squared equals c squared. And these positive numbers must be integers. So 1, 2, 3, 4, 5, 6, 7, 8, etc., and so on. So they must be positive integers, no fractions, no decimals, no negatives. So some examples of these would be 3, 4, and 5. So 3, 4, and 5 form a Pythagorean theorem, a Pythagorean triple, excuse me. So that would be 3 squared plus 4 squared equals 5 squared. So that is a Pythagorean triple. Another one would be 5, 12, and 13. So that means if I do 5 squared plus 12 squared, that would give me 13 squared. And one more example. So 3, 4, and 5 form a Pythagorean triple. 5, 12, and 13 form a Pythagorean triple. And then one more example would be 8, 15, and 17. So that also forms a Pythagorean triple because 8 squared plus 15 squared equals 17 squared. So those would be examples of Pythagorean triples.